Hello everybody, my name is Sandro and this is the presentation for the Capstone 1 for the data talent on the cohort 17. So a little bit of an overview of the data set that I'll be using on this presentation. So this is a data set about hospital admissions data collected on Kaggle, and it's about the data collected from a hospital in India, which is the data is here the Hero DMC Heart Institute, and it was collected during the period of during a 2-year period from April 2017 to March 2019, and during this period there were 14,000 patients that were admitted into this hospital, and 12,000 of these patients, there were a total of 12,000 patients, where 1,900 of these patients had multiple admissions. And the data set essentially contains information about the date of admission and discharge of these patients, as well as the demographics data, patient history, some lab parameters, and some other comorbidities of these patients. I included here on this slide the data source on Kaggle and also how to import this data set on Jupyter Notebook. So my objectives with this analysis is to understand more what is the relationship between the comorbidities of these patients with readmissions, and to try and in a future project create a model that can show the probability of a patient to be readmitted in the future. So some of the limitations that I have with this project is, first, domain knowledge. I don't have a background in healthcare, so this is an area that I have a lot of interest and I'm trying to explore a little bit more. So therefore I have some limitations in how the understanding of the data and the understanding of what's relevant and what's not here. Essentially how old the data is, although the admission of a hospital doesn't change. This data is from 2017 and it might not reflect the accuracy of a current data set today. And the time that I had to perform this analysis as well, it was pretty much built over the time span of a week or so. So it was kind of rushed and I didn't have too much time to explore in depth. So here the analysis that we came up with. So exploring a little bit of the demographics here, I have on this graph, on the x-axis the age of the patients, and on the y-axis the number of revisits that of these patients. So here we can see that there's a little bit of a linear correlation between age and revisits, which can indicate that a patient that is older, as older a patient gets, the more revisits these patients tend to get. The distribution for the age is pretty much follows a normal distribution, whereas the distribution for the revisits pretty much follow a chi-square distribution here. Also, exploring a little bit more about the admissions between rural and urban areas, we can see that pretty much 30% of the revisits come from the urban population, which makes sense because a lot more of the patients came from the urban areas, and 7% of the revisits come from the rural population. About 40% of the urban population were revisits, and about 33% of the revisits were from the rural population, and also females represented 40% of the revisits, whereas males represented 38% of the revisits. And here I tried to explore on this slide here a little bit of the comorbidities of patients that presented only one visit and patients with multiple visits. To try and understand here, my apologies, to try and understand if there was any indication that a potential comorbidity here could show more potential for revisits. So, and here I can see that ACS and anemia and heart failure with reduced ejection fraction and heart failure without reduced ejection fraction, those and the elevation of myocardial infarction, those are pretty much the most significant ones that indicates that a patient can potentially come back for a revisit, and the other ones are less representative, although still representative. So just to explain a little bit better here as well, these numbers are the percentage of the total of these visits. So from patients with more than one visit, the total, this number represents the percentage. So 14% of the patients with revisit had an acute coronary syndrome. 8.3% of these patients had an acute kidney injury, and 2.7% of these patients came back for a third revisit with the kidney injury. 3% came back for a third visit with the coronary syndrome, and so on. And this is the same for patients with only one visit. So this is the total of patients with one visit, and 23% of these patients had an acute coronary syndrome. 10% of patients with only one visit had the kidney injury, and yeah, this is essentially the percentage of this the patients with the number of revisits. And why do I think that this is something that can be interesting to look at? It's because this is potentially these are the variables that are going to be used for a model that predicts the percentage of a patient, the probability of a patient to come back for a new visit. So yeah, and my last slide here is talking a little bit about future projects. So things that I can think of doing with this preliminary analysis that I came up with here is it's a regression model trying to use logistic regression here to determine what is the probability of a patient to revisit the hospital given a certain problem that they are having and given a certain condition that they have. Also, another project that I can think of here is a deep dive on the comorbidities that a patient has, and try to explore the correlation between certain variables, for example, the lab results and certain comorbidities, and also a dashboard to track revisits, and especially with this model, this model that predicts the probability of revisits, to try and help the hospital to track and put more attention on certain conditions that a patient can come up with, can come to the hospital, can visit the hospital. So the administration team can help monitor these conditions closely. And that's it. That's what I have for today. Thank you so much, and please let me know if you have any questions.